So now I'm going to work on the Kaggle competition, do the data analysis. I'm just done doing the JavaScript challenge here in the past. Pretty happy about that. So I think a smart thing to do is to train the data analysis stuff now by doing the Kaggle competition. And I think I'm gonna do several Kaggle competitions. I'm not even gonna concern myself with submitting or getting a nice score. I'm just gonna concern myself with becoming familiar with applying these things here on the data sets. And yeah, I'm gonna do this without a camera now because it's getting late here and it's kind of dark, and I don't want to bother putting the changing the window there to get more light here. So yeah, I think I'm gonna put music as well. And I also think after I do this stuff, I'm gonna work on the Polygon project that I have. I'm thinking about creating a NFT marketplace for Polygon. I think that would be a cool project to put on my portfolio. And also continue to work on the other project that I was doing, which is gathering data from the decentralized exchanges. And I think I'm gonna connect the decentralized exchanges to the Spark and Kafka stuff, so I can get familiar with how it works. I haven't done anything on this project yet. Just was trying to visualize quickly, but I didn't really look into it. Maybe I should open up the Kaggle stuff here. The explanation of the data. This dataset contains information on stock trades for several crypto assets such as Bitcoin and Ethereum, which challenge to predict their future returns. Shortcut, blah blah blah. The public leaderboard targets are publicly available, provided, blah blah blah. Training CSV, training stat, timestamp, asset ID, and ID, code for the crypto asset, count. So that's the part I think I have to understand is the asset ID. The other stuff is intuitive. "15 minutes visualized returns. See the prediction and evaluation section of this notebook. Example test CSV. An example of the data that will be delivered by the time series API. So I guess it's this one. Timestamp is on Unix time. Yeah, so I guess this is the file that has the identification of the which one is it. Asset details provides the real name of the real name and of the crypto assets for each asset ID. G research crypto and unoptimized version of the time series API files for offline work. Mini Python and Linux environment and supplemental training. After the submission period is over, this file's data will be replaced with crypto asset prices from the entire submission period. The current copy has been updated from the original and covers roughly 2/3 of the submission period. I guess this is the one that I'm supposed to train on. Time series API details refers to the time series introduction notebook for an example of how to complete the submission. The API will require 0.5 GB of memory after initialization. The installation step, and that Twitter task will require mini flow more, and that we recommend you do not load your model until after making the call. I guess I'm gonna use let's see, the train CSV to do this stuff, because I don't really care about submitting. I just wanna train manipulating the data, cleaning the data, using one-hot encoding, all these steps for the machine learning stuff, and create different models for training. Hey, Lucian, what's up? I guess it takes a long time because it's a big data set, but I'm not really sure. I know this. So I have timestamp. The thing is that I don't. It's probably not good to use this one specifically to train data cleaning, because I'm not gonna have to use one-hot encoding on this one. It's just numbers. But at least I can do the other stuff. Which part you learn on your school? Spearman rank correlation. Let's see how to do that. Python. I think I need to study SciPy in depth, because there are a bunch of stuff from SciPy that I also have another folder with some SciPy stuff that I was looking at off stream, some functions. And SciPy is the core of machine learning. SciPy, NumPy, and Pandas. So let's see, Spearman. R. It's probably really easy to call. It's harder to understand the methods, but to use is probably really easy. That's just the beginning. We're coding in Python. I didn't have coding when I was studying, but I assume it's gonna be more and more common, since everything is gonna be programming in the future. At least I imagine everything is gonna be replaced by automation at some point. So coding is really all that matters, probably. Use the Spearman R function from SciPy. So raw the Spearman df math. Yeah, so this calculates the correlation between two columns, I think. I don't know how I can do it with all of them. Maybe I can do a loop. Use iLock. No, sort of. Not sure if I really invest in crypto. I traded crypto sometime, but not a lot of money. Just very, like, $500, something like that, some time ago. And I traded, I think. I researched a few that were under 10 million market cap. I don't remember really well. I think I bought. I don't remember the name of the thing, but it was something about computation. And then I doubled my money on that one after researching for a long time. And then outside of that, I just bought the main ones, the top 100, and sold it shortly after. But it's too volatile to invest, I think. It's better to just trade. When it comes to investing, I think it's better. Of course, I can't give financial advice, but I think it's better to just build than to invest. you can't look at all of them. It's too much. You have to pick a niche and then focus on 5 or 10 or something like that. Choose a protocol and then study the protocol. But I think it's better to just build instead of investing, but of course it takes a lot more work to build it. Because it's impossible to know which ones are gonna be worth a lot in the future, which ones are not. And if you build it, then at least you learn something as you do it. So there's less opportunity cost. But I think it will be the future because it just makes sense on the data structure aspect of things, for everything to move towards crypto with the Internet of Things. Because if you're gonna have autonomous systems, we're gonna need to figure out a way to create rule sets algorithmically and make the system depend on that flow of information without relying on central. To some extent, you kind of need central control, let's say. But at least from the database standpoint, I think is probably better with artificial intelligence if you have decentralized, to some extent, decentralized information. So I think it makes sense, not 100%, but to some degree to have crypto. So I don't think it's gonna go away. If I had a lot of money, I would invest in crypto. I'm not sure. Depends. I think I would always invest 100% on myself first. If you look at any smart person, that's what all of them do. They reinvest in themselves and they build businesses. Because at the end of the day, that's all the money is. It doesn't matter which route you go through. It always comes down with, at the end of the day, to systems and ideas. So it's about understanding systems and how to create systems that are good and sustainable, and hopefully achieve synergy. So money really doesn't matter at the end of the day. It's all about information and networking and creating systems that are efficient, and the rest is a byproduct of that. So if you focus on money, you're focusing on the results. You don't have control over the results, so we're always gonna lose. It's better to focus on strategy first, but it's a lot more complicated to do that. That's why people don't do that. And the tendency of human beings is to rationalize because we wanna save energy, minimize risk. So everybody creates heroes and villains in their minds, so they don't have to do anything because their body is trying to make them feel comfortable. So I don't really look at in this way. It's kind of hard to say, like, if you have certain amount of money, what would you do? It really depends on all the circumstances, or all the variables, how much information I have, and yeah. But I think always building first and creating systems and becoming better and better at doing a specific thing, and also connecting with other people that are also good at doing certain things, so I can improve systems and become more efficient in doing that over and over again. And that's all that matters, probably. So I need to see the Spearman correlation. SciPy. So there's Spearman Pearson. Thanks for the follow. I guess it's you, RKZ. No worries, man. Yeah, see you soon. Pearson correlation coefficient and p-value for testing non-correlation. The Pearson correlation coefficient measures the linear relationship between two datasets. The calculation of the p-value relies on the assumption that each dataset is normally distributed. Like other correlation coefficients, this one varies between -1 and +1, with 0 implying no correlation. So SciPy.stats Pearson R. And I guess the way you call is by passing the columns. Maybe I should search for how to find it in all the columns of a data frame. That's the kind of the thing that bothers me about the way that they tell you to do things in machine learning right now, because it doesn't seem like there's a clear way. It's just more about testing a bunch of stuff, and you don't really have any, let's say, standard is more about art than science, let's say. But I understand why is that is the case. That seems to be the case right now. pd.get options display max columns. What does this do? Am I supposed to do it on the data frame? Let me just run and see what happens. Oh, I have to comment this. Because the thing is, it always depends on the thing you're gonna analyze. That's the thing. I guess that's the main thing that I don't like, is that you're not really getting anything fundamental from doing this data analysis. That's why it's so annoying to me. Because yeah, you gotta find the relationship between the points, but then it all comes down to what's the epistemology of data. I guess it works when it comes to games, because, or anything that will have large amounts of data, but then you're gonna have long-term implications on that, because we don't know the epistemology of science. Where does the data come from? And yeah, but I guess, yeah, that's the problem, because you can't really get out of that, because you're always trapped by the scientific paradigm, because of the hard problem of consciousness. You reach the block, the roadblock there. That's the problem. So guys, the question is, what am I trying to capture here? That's the thing. When I'm analyzing these relationships, what's the underlying fundamental stuff that I'm trying to see the relationship between these data points? So I guess this works in the same way from the other ones, but you use a different function where you pass the columns, the series of the data frame, and you get this relationship. Yeah, I guess that's the thing. Because it doesn't matter if I do these things here if I don't understand the fundamental relationships of the things that I'm trying to predict. That's the problem, I think. So I need to think about it in a way. I need to think about the problem first. It's not about just doing these relationships here. Because it seems quite easy to do them. You just look through the columns and then you create a variable and you replace the variable to get the relationship between all the columns. But then the issue is, what do you do with that and why do you do it? That's the thing. Maybe I need to study more the theory. It doesn't seem like it is hard to apply this, so it really doesn't. I don't think it's gonna make me better by applying this. I think it's gonna make me better if I try to understand what I'm trying to do first, the principles behind it, and then try to integrate in the own way I have on my mind what I should do. I'll press Ctrl V here to see the source code of the function. Maybe I should do this simple thing first and should capture this relationship between any of all of the columns in this thing. So I think I'm gonna look it up on how to iterate over columns. I think it's df columns probably. So for item, df columns, print item. I think this is gonna give me all the columns. But I think I should probably research the best way to get the relationship between all the columns. So I think that's the first thing I'm gonna do. I'm gonna get these correlations, and these relationships between all the columns is Pearson and Spearman, and then I'm gonna put them on a dictionary probably. And after I do that, then I'm gonna search for the source code of these functions to understand how they are built. And then I'm gonna try to think about the physics behind the data. So maybe I can create something that is more related. Yeah, I have to think a lot because I'm trying to understand how the models work fundamentally. I think that's the main priority I have here. Yeah, I think I'm gonna have to do an nested for loop, or do the for loop of the columns, and then I apply this lambda, this dot apply lambda, or maybe this is already the nested for loop. Pass the series special call. So instead of a special column, I can use the name of the column here. I'll make this equal to B. And then this is probably gonna give me all the relationship between all of them. But I wonder if there's a way to make it faster or better than this. I think I'll bring it back. Let me wait to see if this is gonna return or anything. So what I'm thinking about is getting all these relationships relationship between these things, and then I have to think about the physics behind it. So this is price movements of crypto. Okay, so sprinting only once. Oh, okay, so it didn't stop. So I guess this works for all of them. Kinda slow, but seems to work. Yeah, the only issue is that I don't get the name, I think, of which one is being compared. Oh, okay, I can just print the item here, and then I'm gonna know which one is, but I guess this works, and I can do this for all the other correlations I went, I guess. It's not that hard. So let me think. I think I will be right back. So what makes this so difficult is that I guess another thing I can do is try to build the models, the simple models that exist using sklearn and train test split. That's another thing I can do, sure. Train the way they tell you to do. Now obviously that's not gonna be good because it doesn't really work that way. And that's exactly what makes this so difficult, because I'm trying to think about the relationship between pressure, volume, the density of information, and the analysis of the data, and the geometrical aspect of the market movement, and how to incorporate that into the model. That's the challenge, and that's the problem. Because if you're only feeding the data into these functions, if you're getting the data and trying to fit trying to do the machine learning process of feeding the models into the data. What you're essentially trying to do is to reduce the data, the volatility of the data into functions. And obviously it's not deterministic, so it doesn't give you anything. That's the issue. And then if you want to get a more realistic picture, you need to think about ways to capture the physical relationship between the data and the dimensions of the data. What is influencing the movement of price, which is pretty much everything. All the impulses, So there is not easy because there's a lot of things that I can do, that I need to do in order to get a better accuracy, like putting brain information and then I have to research that, and then putting Twitter and social media info and analyzing that and putting them in the model. Just doing these models is not gonna give me anything. Like, and I guess that's the problem I have, is just meaningless to do the models with this data. But maybe I should do it just to get some practice. I think I'm gonna run this again just so I get the name of each one. I should probably print on separate lines. It's gonna be better actually. So I guess maybe I should think about different ways to incorporate physics into this, some physics calculations, after I build the models using the simple stuff. What I was thinking about is how can I capture the relationship between density of computation, how frequently you get information, and you consider that data, and the probabilistic paradigm, let's say. So what's the connection between past and future? I think it's gravity. But then I'm not really sure if I understand all the theoretical physics, which is really advanced for me. General relativity, special relativity, and quantum mechanics, that kind of stuff. But I guess that's the main thing that's missing for me here. Is how can I incorporate the frequency and density of the computation with the prediction. Because how fast you get the data determines what your biases are going to be towards the probability. In a way, density, that's all the density is, in my eyes. The more dense something is, the higher the probability that that thing is going to be perceived from an observer as an object. So less density is more uncertainty, but everything, all the boundaries are illusions. So that's why it's fractal on the surface. So how do you measure this relationship between the density of things and the probability distribution that makes up that object be what it is? So maybe I should research on density. Yeah, the problem is that it's not three-dimensional space, it's high-dimensional analysis. That's why it's so difficult, because when I'm talking about density, I'm not just talking about density of space-time, because the relationship between the data is abstract, and that's the issue. So how do we get the density on the abstract portion of the data? Because whatever concept determines something to be is going to have nested, embedded assumptions into it, because everything is connected with everything else. It's like a electromagnetic model, I think, of whatever that thing is, because each concept is like a tree, a game tree that is connected to everything else, which is a self-fulfilling prophecy. And then you get the hard problem of consciousness, because you can't say anything about the thing that gives rise to the data. That's the issue. So this is timestamp, asset ID, and I guess I'm getting all of them. Count. I guess I could make a dictionary and then pass all this stuff into the dictionary. Sphere correlation, Pearson correlation. I don't know what this is. Go here. So I'm gonna make a dictionary called, maybe put it like this, probably better. And then I can make the values of each one, depending on what type of correlation it is. Yeah, but then I need to put the item as well, that's the thing. Well, let me think. Because it has to be nested. It has to be 2 levels of. Because they have both the name of the columns and the name of the correlation. And then it gets really complicated, the data structure. Or maybe it's easier if I make multiple dictionaries, each one for each correlation. And then each key is gonna be a column. The challenge for me is that I want to make sure I'm training the simple stuff. That's the problem. Because if I start thinking too much, then yeah, the issue is that I don't I can't train this stuff knowing that it doesn't make sense to do it this way, because I don't really believe in it. So this is Pearson correlation. Yeah, this is the same thing that I'm doing, probably. Yeah. So maybe let me read on Pearson correlation again, just to see if I understand really well. I guess it's the linear relationship between data series or data arrays. But measuring linear correlation. It is a number between -1 and 1 that measures the strength and direction of the relationship between two variables. I think I'm gonna create another file called model, and then I'm gonna do the model stuff here. I think it's preprocessing that has string test split, if I remember correctly. Yeah, probably not, since it's not giving me anything. I'm just gonna search for it. What I'm thinking about now is how do concepts correlate with the physical relationship in data? How does meaning correlate with geometry? That's the question here. Because if I want to put other physical relationships in the data, they're not just getting the derivatives and doing the gradient descent stuff. I need to understand where's the bridge there, how I can connect the meaning with the physical relationship. That's the challenge, because the only way to make it work is to unpack the meaning on the physical relationship that gives rise to that meaning. So you find the relationship between things that are connected only through the abstract notion of ideas of what it means for something to have a price or a volume or things like that. Like, what is money? Exactly. It's just the computation of the limbic system and the prefrontal cortex, or the brain, of how much something is valued under certain circumstances. I guess I'm gonna build the simple models first, so I don't get too caught up on the abstract stuff. And I'm gonna build all the models, probably. So sklearn, train, test, split. So the first thing, you separate the data using index, because it's sequential, so it can't be a random split. And then you have to remove the column as well. But that's the thing that I'm not... Yeah, I need to practice this more, because I understand it, but I don't remember it really well. Yeah, I guess, let me see, there is a target here, target. So maybe I should put train X instead of this, or test X. Equals df equals target. There we go. And then I don't remember really well how to do this. I think it's string X, string Y, test X, test Y. But I don't really remember exactly how to do it. Maybe I should go to the source. Yeah, this one is where the size goes. Yeah, that's the way that they do it. So xstring, xtest. Should just copy this stuff here. And then x and y would be this true, I think. Not really sure. And then I'm not gonna use the random state as well. I think I'm just gonna look it up to make sure that I understand what's going on. Because I know what you have to do is pretty much split the data in percentages. It can't be random because it has to be the sequence of the data has meaning. So if you split randomly, you're gonna lose the meaning of the sequence of events. And then from that, you select the target, the training set, the target is gonna be the column that you're gonna try to predict, and the rest of the data frame is the training, the x, which is gonna be the data frame without the target, and then you split it in usually 80%, I think, for training and 20% for testing. But maybe I don't even need to do this because in this case it's already separated, but I'm gonna do it anyway because the point is just to practice. I think I can also look at the Kaggle competitions, not competition, the courses that I did. Let me make sure I don't show anything that I can't. Because I remember doing this sometimes. Yeah, maybe it wasn't here that I did it. So I think I'm just gonna search through here. Yeah, that's the way. So task size, I think I'm just gonna copy this here. You can get rid of this stuff. Let's say you want to use the last 2 years for testing and everything else for training. You can use Python's lesson notation to split the data sets. It feels like I'm missing something. Because I'm not getting the targets and the data frame. I also need to practice doing this cross-validation stuff. Oh, actually, oh no, it's the correct one. I thought I was copying on this one for a second. I think I'm gonna erase this part here. So it is the way that I did it, I guess. But they are using random state. Which doesn't seem like it is the correct way to do it. And I remember you can use pipeline as well to create a pipeline of this stuff. I guess I don't like doing this stuff because it's really boring and it's not. It's too easy, I think. It's more I get it, about it's not that it's too easy, it's just repetitive. It's more about getting the reps in than actually doing anything that's good. Because I already know the concepts behind it, and it's more about just doing a bunch of repetition to memorize how to build this stuff. So it's not exciting for me. Because in order to reach flow state, you need to do an activity that's slightly harder than your skill level. There's another thing that I can do is look at the solutions from other people, just see how they did it. But I think I'm gonna do that after I have a simple model first. I think I'll be right back. Right, I'm back. Probably can't trust this one also because they're randomizing. Or maybe not. I guess that's it. That's all you have to do. But it feels like I'm missing something, I don't know why. Maybe I should just print this stuff. Then if I remember correctly, you have to create the layers using sklearn. Then depending on which model you use, you can get the object, put the object, put a variable, make a variable with the object that creates the model, and then fit the model into the function and test. And that's it. And if you have a data frame with columns that are not numerical, then you have to do one hot encoding. Sure. So maybe probably this thing here is incorrect. And then to facilitate, you can use the pipeline where you put the steps, data cleaning steps. Oh, and you can also do cross-validation as well. Cross-validation, then you have the heat map stuff that I think is Spearman correlation. And then you can do that. You can see which ones have a higher or lower correlation to eliminate or to test with different columns of the data frame. And then you can also create other columns based on the relationship of the ones you have. Maybe I need to pass access equals 1. I think it's, I don't remember really well. Oh, maybe I'm passing the series, but I need to pass the name of the thing. That's probably the reason why it's giving me that. And I think access equals 1 as well, so that I'm removing the column and not rows, but I'm not really sure. Yeah, index or column label should drop. A tuple will be used as a single label and not treated. Access 0 or index 1 or columns. Yeah, so 1. So it's 0 by default, which is rows. And then if you want to drop columns, you need to make access equals 1. And so this is the line that I'm getting an error. Oh, it's because it's lowercase d. Not lowercase, uppercase d. So the issue is that the reason why I don't like doing this stuff is because I already know what to do and how to do it, but I don't really remember off the top of my head. That's the thing. So I just need to do this a bunch of times until I don't have to research each time I'm gonna do it, what methods to use and how the steps for each one. That's why it's annoying. Because I know I'm not gonna discover anything new by doing this. Or useful. It's more about getting the reps in. And the borrowing repetition. I keep looking at this just to see if I'm forgetting something, but I don't think I am. Of the things that I need to... I think it's only Spearman and Pearson that... And then the additional step is that people do, I think, is to get the SNS graph, which is gonna show the heat map or how correlated it is. But I think that's it, and then also you can do this one using apply. But this is to get the cumulative sum, which I don't think it makes sense. And this is to fit an exponential. And F1 score just to get the relationship between false positives and negatives and the score overall of the model. So I think I can close this one. Maybe I can look into cross-validation stuff, because I don't remember really well. And it seems like this is the correct way to do it. Maybe I should do length of each one, just to see. It looks like I'm getting the data frame. String X test. So the first step is to split, then to do the correlation, then the cross validation, and then create the models and test different models, and then you can do future hyper tuning or hyperparameter tuning, which is changing the algorithms for gradient descent and changing the other stuff, the columns and things like that. Just see if the score improves. And also just save the model. Also need to just see that, which I think is something with job something, or you can do just do the pico dump to deposit in, to dump in a binary file. I think I gain more by studying the source code of each one. It's probably gonna be a lot better to learn than to just do this stuff. But the issue is then that I don't become good at applying the stuff that already exists. I probably need to do both. Yeah, so it seems like it is correct here. So technically, all we need to do now is to fit the model, create the model, and then fit the data into the model. Because I'm skipping the other steps, and because the data is only numerical values. But I guess outside of that, the only thing you would do is just see the correlation and then see if you can drop or add columns to create new columns. Change the features, basically. Hyperparameter tuning to improve the score. So maybe I should look it up on how to... Yeah. Oh, and I forgot about this as well, which is replacing the missing values with some of these methods. Grid search CV. So guys, I can do that. I can print to see if there are no values. I forgot how to do that. I think it's the app. Remember there was some or something like that. I know you can use fill NA or drop NA to drop new values. But I guess I can get the new values from the data frame and then replace with one of these functions. And then create the model. And also look it up, the grid search CV stuff. Yeah, is no dot sum. Just see the count. Oh, this is for hyperparameter tuning. So I guess SN symbol is where the models are located. Oh, so they have also this one has 9 no counts apparently. So I guess I can replace the new values on that one by using one of the functions here. Let me go to the source code and see. I don't understand why should I pass the min and max values. But I was thinking about doing from 0 to the highest value of the column. So guys, this is the first value you pass. Well, I guess this already computes the minimum and maximum value of the data you pass. And then it does the replacing on a range from 0 to 1 from those minimum and maximum values. Yeah, I guess this is one. I'm getting tired already, to be honest. The thing is, I'm reading this, but there's a bunch of stuff in my mind simultaneously while I read through this. Yeah, so I guess this finds the minimum and the maximum. This finds the minimum, the other one finds the maximum. So I guess it's just as simple as calling this, then doing dot fit. And then x. And here I should put x as well. There we go. I'm not sure if I need to do this equal to anything. Probably not. I guess you just call this and then you replace the new values with whatever. So let me just see if that's the case. I guess I'll just do the count. Yeah, but outside of this, let me see if I'm missing any steps. So first you split the data. Well, first you have to, you need to do this stuff first before you split the data. Otherwise the data is going to be different, obviously. So I think first thing is you replace no values Then, well, first thing you probably change the categorical columns into numerical, and then you separate the target from the data, from the rest of the data frame. Then you do the Spearman correlation and the other correlations. Then after that, you replace, well, before that you replace no values, then you do the correlations. Then you do the train test split. Then after that you create the models and you fit the data into the models, I think. Oh yeah, so I need to put only the column here and not the data frame. That's the thing. So I guess I can do the loop if I want to do this function for all the columns that have new data. I'm trying to think if there's a way to do the function for the entire data frame instead of passing specific column. I think the volume is the one, view warp, the one that has new values. I'm just gonna do like this to see if it's gonna break or not. The only way that comes to my mind right now is doing the loop between the from the columns, the same way that I did on this one, and then putting the column here. Maybe making if statement if no counts different than 0, and then calling the function. Should replace. I should probably actually make the. Yeah, I'm not sure if I do need to make x, the column, equals to this, so it actually changes the column, or if I just by calling this, it replaces the values. So it expects to the array. So maybe I do need to. Oh, actually, probably this is the thing. Yeah, I'm not sure if this is gonna give me the data frame. It's probably the mistake I'm making here. So you do need to pass the data frame here, probably. No, but that's exactly what I'm doing here. So I don't understand what's going on. I think I'll be right back. I'm back. Yeah, it looks like I'm getting the data here. So I don't understand why this Mimax scaler is not working. I think I'll take a break soon, probably, because I'm getting tired already. I think a good idea might be to just look at a bunch of competitions and try to analyze the patterns on the code from other people until it becomes, oh, so now it's working. Weird. Or maybe not, because it's still running. Yeah, now it fails. Input X contains infinity or a value too large for D-type float 64. I don't understand. So maybe it's saying that one of these values is infinity, which doesn't make sense. Hmm. So maybe I should put it like this, is no. Or maybe I should do no counts here instead. Oh, but no, it's not sum. I don't get it. Because I think I know exactly what to do. It's just that I keep forgetting the methods and the process of doing this stuff. So it might be good to just take some time to look at a bunch of solutions from other people and see what they do. what they're usually doing, and then maybe try to look at the solution, then write the solution without looking, see if I remember the steps, and do this over and over again. Because it's not a matter. The reason why I'm doing this is not a matter of understanding anymore. I think I already understand how it works, everything. It's just a matter of remembering how you're supposed to do each method in the code. It's more about memorizing. And then once I memorize all the steps and the process, then I can go back to thinking about different ways to incorporate other concepts or maybe study the source code to understand more how it works under the hood. Yeah, so now it works. So I guess it wasn't working because I was passing values that are not null and you're only supposed to pass the null values on this one. But it's still, yeah, I guess it doesn't change the data. You have to make it equal to it. So maybe min max scalar Python. I hate this articles where they put a bunch of stuff that doesn't matter just to make it look bigger. Okay, here's the code. So fit transform. And the data is supposed to be the data frame. So maybe I'm calling a different method. Fit transform. Try if the X here. Or maybe I should be printing this instead because it might be the case that I'm gonna get the same value just because I initialize it before I do the fit transform. And if I do it like this, it might change the actual value. So I need to remember exactly what imports are usually done, what's the sequence, and how is this stuff done? How is it written exactly? So I don't have to keep looking each time. I can just remember by memory what steps to do and how to do it. But I guess this is helpful as well. It's gonna help me remember from the mistakes I'm making. Same issue from before. Think I'm gonna watch a video about this.
In this video, we will learn about min-max scalar. It is a standardization process in which the feature values lie between 0 and 1. Let's import pandas as PD. I'm going to make one. variable df, and in that variable I will save my CSV
I
file.
guess I have to change the range actually if I want to use it, if I want to fit the whole data. And that's the problem, probably the reason why it's giving me that thing, because it wants values from 0 to 1 by default, but I'm passing the values in the data, so it doesn't work. So I need to pass a different range if I want to fit the data, the whole data frame, instead of only the no values.
From pandas I will use the method read underscore CSV,
And it's still
and
not
inside
changing
this I
here.
will pass my CSV file name. Let's look at the top 5 rows of a data frame df. We will use the method head. These are the top 5 rows of a data frame df, and it contains columns such as mpg, cylinders, displacement, horsepower, weight, acceleration, model year, origin, and car name. Let's also look at the bottom 5 rows of a data frame. We will use the method tail. These are the bottom 5 rows of a data frame. Min-max scaling can be performed only on numeric data. So let's look at the data types. We will use the method dtypes. We will write df.dtypes. In the output, you can see that we got the data types of each variable. So MPG is float 64, cylinders, integer 64, displacement float 64, horsepower, object. So we cannot perform min-max scalar on horsepower because it is an object. Weight is integer 64, acceleration float 64. For this tutorial, we will consider two variables. We will consider displacement and weight. I'll make one variable x, and this variable will contain all the features or all the independent variables. So we are considering only two variables, displacement and weight. From df, I will use the method ILOC. I want all the rows, and I want only two columns, which is displacement and weight. So we need to put the index number of these columns. Let's find the index number 0, 1, 2, 3, and 4. So the index number of displacement is 2, and the index number of weight is 4. We will type here 2 and 4. Now we will make one more variable, which is going to be a target variable y. And in this, we will consider one variable. For target variable, let's consider acceleration. So the index number of acceleration is 5. 0, 1, 2, 3, 4, and 5. So I'll type, I want df.iloc. I want all rows, and I want the column number 5 only. Now we are going to import min-max scalar and train test plate from sklearn. From sklearn.preprocessing, we will import min-max scalar, and from sklearn.model selection, we will import train test split. Now we are going to split our data into train and test. We will make variables xtrain, xtest, ytrain, and ytest. And we will use the method train test split. Inside this, we will pass our data frame x and our target variable y. We will also pass a random state. And here I'm passing number 50. You can pass any number here, but if you want your result to be same as mine, then you have to pass 50. And I'm not passing here test size because I'm not going to make any machine learning model. I'm just explaining you how we can apply min-max scalars. That's why I'm skipping that parameter test size. Let's execute our code. So we have split our data into xtrain, xtest, ytrain, and ytest. First, we are going to perform the min-max scalar on this variable x underscore train. So let's look at x underscore train, xtrain.head. So we have displacement and weight in our data frame xtrain. First of all, I will make an object of min-max scalar. I'm not going to make any machine learning model. I'm just explaining you how we can apply min-max scalars. That's why I'm skipping that parameter test size. Let's execute our code. So we have split our data into xtrain, xtest, ytrain, and ytest. First, we are going to perform the min-max scalar on this variable x underscore train. Let's look at x underscore train, xtrain.head. So we have displacement and weight in our data frame xtrain. First of all, I will make an object of min-max scalar. So I'll make one variable scalar, and then I will call min-max scalar. Now I'm going to fit this on xtrain. So what here I'm doing is I'm creating an object of class min-max scalar, and then I'm fitting our training data xtrain. Let's execute. Now I'll print scalar. In the output, you can see that it is an object of class min-max scalar. We have just fitted our min-max scalar on x underscore train. We have not applied the transformation. Let's look at some of the functions which are available in our object scalar. We will say scalar dot data underscore min. So the minimum is 68 in our variable displacement, and the minimum value in our variable weight is 1613. We will also look at maximum scalar dot data dot maximum. The maximum value in our variable displacement is 455, and the maximum value in our variable weight is 4997. And we can also verify this using the describe method xtrain.describe. And here you will see that the minimum for displacement is 68, so we got here is 68. The minimum for weight is 1613, we got 1613. The maximum for displacement is...
Yeah, so it doesn't look like what I was talking about is the reason why it's not working there. Because obviously it has values that are not between 0 and 1, and it's working, so I'm not really sure what the problem is on the way that I'm doing here. The only difference is making like this, but it should be working. I don't see any reason why it wouldn't be. Then the thing that I also don't know is It doesn't look like it changes, it actually changes the original one. It creates a copy. So maybe you need to make the previous one equal to the new one. I'm not really sure.
455. Here we got 455. The maximum for weight is 4997, 4997. So we got the same numbers here. We will also look at scalar dot feature underscore range. So the range is 0 and 1 because when we are going to transform this variable displacement and weight, all the values will lie between 0 and 1. No value will be less than 0 and greater than 1. So far we have just fitted our x train. Now we are going to transform this. So we will say scalar dot transform x underscore train. Before transformation, we have to fit, and we have done fitting here. You can see here I have made an object of min-max scalar and I have fit x train and saved in the object scalar. So after the fitting, now here I'm transforming. Now let's print. In the output, you can see that these are the transform numbers of our variable displacement and weight, and you can see that all the values are between 0 and 1. So here it is 0.11, then the maximum value will be 1. So here you can see 1. This is the maximum value. There will be no value in negative or greater than 1. All the values will be between 0 and 1. So when you apply min-max scalar, your values will lie between 0 and 1 after the transformation. And we can also save this result in a variable. I'll copy this code from here. I'll make one variable x underscore train underscore scale, and I'll just paste that code here. Now I'm going to print this print x underscore train underscore scale. So these are the transformed values of our variable displacement and weight, which we can use for our machine learning model. So we have done this transformation on training data. Now we will do the same transformation on test data. I'll make one object scalar, and then I will call min max scalar. Then I will fit this on x underscore test. Now let's print our object scalar. So you can see that it is an object of class min max scalar. Let's also look at some properties. The minimum. So in our test data, the minimum value for displacement is 70 and for weight it is 1649. Let's also look at the maximum value. Scalar dot data dot maximum. So the maximum value is 455 for displacement and 51404 for weight. Let's also look at the features. Scalar dot feature range. So the value will be lying between 0 and 1 after the transformation. And we can verify this minimum and maximum by applying the describe function on xtest. I will say xtest dot describe. In the output, you can see that the minimum for displacement is 70. And here also you will see 70. The minimum for weight is 1649, and here also 1649. The maximum for displacement is 455. We will verify. So it is 455 for displacement, and the maximum value for weight is 5140, 5140. Now we can apply the transformation. We have just fitted here. You can see that we have fitted here, and now we are going to apply the transformation. So scalar dot transform, and we have to pass our x test. In the output, you can see that these are the transform value of our x test, and this one is for displacement, and this one is for weight. You will see that all the values will lie between 0 and 1. No value will be negative, and no value will be greater than 1. The maximum value will be 1, and the minimum will be 0. You can see here that the minimum value is 0 here. And you will see here the maximum value is 1. Here also the maximum value is 1. We can also save this result in a variable. I'll make one variable x underscore test underscore scale, and then I will copy this code from here, and I will just paste it here. Let's run our code. Now I'm going to print this print x underscore test underscore scale. In the output, you can see that we have saved the result in a variable x test scale. This is how you can apply min-max scalar on your numeric variable and use it for developing machine learning model. This video was about how to transform your variables using min-max scalar. If you like my video, please subscribe to my channel. Thank you for watching.
Maybe we should just copy this value error here and see what happens. And search for this. It might be because of the data type, and I have a value that is bigger than what is supported by float64, and that's why it doesn't work there. It doesn't make sense to me. Should be the known values, because then it would defeat the purpose of the function itself. That doesn't make sense to me. I guess I can just do this one, which is the easier way. Just replacing with the meaning of the columns, but I want to understand how the min-max scaling works.
Namaste. In this session, we are going to look at min-max scaler. Now, min-max scaler will scale the range of each feature to be between 0 and 1. Okay, so whatever be the actual range of the values, it will scale them to be between 0 and 1. Now, min-max scaler could be used when the data is not normally distributed. As we saw in the previous class on standard scaler works well on features that are normal-like. Okay, so it is useful when a feature follows a normal-like distribution and not so much otherwise. So when we say not so much otherwise, you can use a min-max scaler on features that are not normally distributed. But there's also a caveat here that it does not perform well on features that have outliers. So it is sensitive to outliers, and we'll see why it is sensitive to outliers, and it also does not change the shape of distribution of that feature. And we'll see this as well in the plots. So how does min-max scaler work? So now for each feature x, for example, if we have this age feature, then we first calculate the minimum of all of these values. We find that the minimum is 5. It is not 0, actually, it should be 5.
I think I'm misunderstanding how it works. It's not supposed to replace the null values. This is supposed to rescale the data. Yeah, it's another thing. That's why I'm confusing the two. So this is used when you have data and you wanna, for whatever reason, maybe because the values are too different from other ones, so you want to rescale the data. And I'm confusing this with something you use to replace the null values. So this one is probably better. Let's see if this changes the data. Changes the null values or non-values into the mean of the whatever the column is. I think I'm just gonna look at the model then and then try to fit the model. Apparently, I think it works. Or maybe not. What? So it's saying here is 6, but here is 9. So there's more null values here. Which doesn't make sense to me. So maybe I do need to make x train equals this. And then it's gonna change. I think that's the thing. Or is it because I'm doing with x here? That's why. So maybe I'm gonna try the other one again, and then if it doesn't work, I'm gonna make x train equals x train. Yeah, so these steps are pretty simple. I'm actually not really sure what exactly I had trouble with when I was doing the test for the Turing stuff. I don't remember really well if I knew how to do this stuff, and it's just a matter of knowing without searching anything, or if I didn't know what they were asking me to do. And so it still has 8 here. So I'm gonna try to do like this and see if it changes. I should probably also erase this so it's faster. I don't think it changes that much, to be honest. Hmm. So why this doesn't work? Doesn't make any sense. Uh. I understand why making it equal doesn't work, because this probably doesn't return any value, but it should be working when I'm just calling the method to replace. I don't see why it doesn't.
I'll just update it. So the minimum value is 5, the maximum value is 49. Okay, so what is this new xi? This new xi will be the initial xi, that is, for example, 5 minus the minimum is 5 again, so 5 minus 5 is 0, and hence the scaled value is 0. Then for the next, for example, for 10, we'll do 10 minus 5 upon the maximum is 49 minus minimum is 5. So 49 minus 5, 44. So we'll do 10 minus 5, 5 upon 44, which will give us 0.11. Then similarly for all of these features we'll do. Now for the maximum value, this is 49. So we'll do for the 49 value, we'll do 49 minus x minus 5. So this is 44 upon x max is 45 minus 49 minus x minus 5. So this is again 44. So 44 by 44, this will give us 1. And hence the maximum value in the scaled is 1. And the minimum value is 0. So you see now all the values have been scaled between 0 and 1. So this is what min-max scaler does behind the scenes. Now if you check out the plot, this is a similar plot. So it also scales the values to be between 0 and 1. So now all the plots will have values that range between 0 and 1 only. Okay, so if you see in the standard scaler, it went from -3 to +3 and -3 to +4. But in min-max scaler, it will go from 0 until 1 for all of these features. Now why does it does not perform well on features that are outliers? Well, that is because if we just assume that the maximum value here is 120, then the x max will become 120. So the whole calculations will get skewed, and the outliers will therefore have a very huge effect on the scaling. Okay, so this was all about min-max scaler. Now we will look at a practical implementation in Jupyter Notebook.
Maybe it's because of the axis here. Oh, no, but it's the same value. And here this is probably wrong as well. I should be doing this outside of here. Alright, this should be just df. And in place equals true there, probably. X is 1, in place equals true. I think I'm gonna do the rest of this off stream, to be honest. I'm already tired and I think I'm gonna take a break and then do the rest of this stuff off stream. And once I have, it's probably not that difficult to do the model. You just create the model object and then fit the data, so. And I think next time what I'm gonna do is look at the solutions for a bunch of, not only this competition, but for a bunch of other ones, and then I'm gonna try to copy, just create a file and write the solution down without looking, just to train my memory, and I'm gonna do this a bunch of times until until I can remember the methods by memory. Because I already know the stuff that I have to do and the steps and how it works. Then once I do this enough times, I'm gonna do the test again to do the Turing tests. And then after I do that, then I'm gonna think about how to actually make improvements and probably study the source code as well for these libraries to understand better how they work under the hood and the fundamental stuff. And I'm also gonna work probably on the other project in order to try to incorporate Kafka and Spark on the datasets from crypto, the information from the crypto decentralized exchanges. So next time I'm gonna look at the solutions. I'm gonna do this off stream and I'm gonna talk about what I did next time, the model, and look at the other people's solutions and do the training stuff until I memorized everything. So see you then.